a very active couple of days. Look at this footage. Wow. Pretty sure this is from Rome. And then here's another one. Guys, this is just too much, man. This is it. This is it right here. Look at this. Look at this. Oh my. Guys. Really? Really, man? Look, this is why there's no time for drama. There's no time for, like, hand-wringing. It's time to come together. It's time to come together. It's time to come together. Because this is real. I look at this, man. I have never seen anything like this before in my life. I'm just going to play it for a second. Next video is going to be, we had a teamwork incident. Remember, tomorrow morning, get up, try to see if you can get this thing on camera if there's clear sky. That's why they've been chemtrailing, guys. Look at this. Dave Dobbs, you might be right, bro. Oh my, oh my, oh my. No wonder they're trying to discredit us right now. No wonder they're trying to discredit us right now. Guys, we're the ones that can get this stuff. You know why? Because we're a huge worldwide network of 70,000 people that all think alike in terms of wanting to know the truth. I'm not saying that we all agree. I'm not even sure what I'm looking at right here. It could be any number of things, but it's most likely a planet. I don't know what else to tell you, guys. Next video is going to be about all the findings that we had in Rome. We had a huge sighting in Rome. That's coming up next.
Consider that the magnitude 9.0 earthquake in Japan, just a few years ago, remember that? Killed more than 15,000 people in the north of Japan and injured thousands of others. Seismologists say that the quake that will strike on our Pacific Northwest coastline should be even stronger, at up to a 9.2. They call such a quake a margin rupture quake, and it's every bit as bad as it sounds. Here's the reason for it. Our entire continent sits on the North American tectonic shelf, right? Plate, I should say. Off the coast of the Pacific Northwest, from the top of Washington State all the way down to northern California. This is it. And another plate called the Juan de Fuca is trying to slide up under North America, but it's stuck. We have an illustration over here in the big wall. Let me show you what this is. This is our continent here. This is the Cascada Mountains. This is the Cascadia, what do they call it? The Cascadia what? Bridge. The Cascadia Bridge. I was actually asking him, but thank you. The North American plate here and the Juan de Fuca plate here. This one's sliding up under, and eventually this is going to go down, send a huge wall of water up. That wall will go all the way over to Japan, and the other will come onto our shore within 15 minutes. And when it slips, it will unleash not only a colossal earthquake, but also that tsunami, 700 miles long, and in some places up to a 100-foot high wall of water and whatever it's pushing, like houses and dump trucks and schools. Thousands and thousands will not escape. The New Yorker quotes a FEMA official who says, and I quote, "Our operating assumption is that everything west of Interstate 5 will be toast." Everything west of Interstate 5 is gone. That's Seattle, Tacoma, Portland and Olympia, Salem and Eugene, wiped out. Altogether about 7 million people. That's not including tourists. So think of summertime. The New Yorker reports that FEMA calculations indicate the disaster will damage or destroy about 1 million buildings, including 3,000 schools and 1/3 of all fire stations. And perhaps the worst part of all of this, these sorts of earthquakes happen at regular intervals in exactly this part of the world, have forever. On average, according to seismologists, about every 240 years. So when was the last one of these massive 9.2 or so earthquakes? Well, the last one was more than 300 years ago, the year 1700. It struck in the Pacific Northwest and sent a 600-foot wave of water all the way to Japan. So right now, on average, the Pacific Northwest is decades overdue for the really, really big one.
CBS News science and futures contributor Michio Kakuka is a physics professor at the City University of New York. Good morning.
Morning.
So it's overdue. When will it might come?
Well, this is the mother of all earthquake faults. It can pack a wallop 30 times that of the San Andreas fault. So forget all the Hollywood hype about the San Andreas fault. We're talking about an earthquake, a 9.0, similar to what devastated northern Japan, which killed over 15,000 people and caused $250 billion in property damage.
Cascadia subduction zone stretches about 700 miles from Cape Mendocino, California, to Vancouver, Canada. Big cities expected to be affected include Seattle and Portland. Some scientists believe the earthquake, when it goes off, will reach between 8.7 and 9.2 on the Richter scale and cause a tsunami.
Airmen and soldiers conduct joint training in Washington to support domestic operations in preparation for a natural disaster.
As president of the Portland Post of the Society of American Military Engineers, I felt a real need, a real desire to mobilize engineers to help better prepare our region for a Cascadia earthquake.
Army and Air Guard elements successfully operate in a joint mission environment. The only way to move supplies and support to stranded residents in need after such an event would be by air.
It's really great to see the state move in a direction of supporting domestic operations at this level. It allows us to really be much more dynamic and respond to the state and to our community.
The last big one was 315 years ago. We think the cycle time is roughly 240 years. Do the math. We are overdue in this calculation with another big one.
We've known about the Cascadia subduction zone for quite a while. It's a serious risk. A big earthquake in the Pacific Northwest could be the worst disaster the country has faced historically.
Every day, almost to the point where it would make your head spin. In order to slow down that pace, it's important to explain what's happening one event at a time. Similar to placing the pieces of a puzzle into one uniform picture that can be easily recognized and identified. One of the pieces of the puzzle that has stirred a great deal of attention has to do with the intensity of seismic and volcanic activity in the northern hemisphere, along the Cascadia subduction zone and the Aleutian Island chain in Alaska. Most recently, seismic alerts have centered around the Yellowstone supervolcano, where a swarm of earthquakes reached nearly 900 in just 2 weeks. This is the highest number of earthquakes in the past 5 years for this short of a time frame. The last volcanic eruption within the caldera was 70,000 years ago, so it is well overdue for another outburst. A swarm of some 100 earthquakes hit Switzerland on July 1st, with a 4.2 quake that was felt over much of Switzerland. Following the earthquake, some people reported noises and booms after the shaking that lasted between 2 and 10 seconds. One of the biggest volcanic news stories of this year concerns the vigorous and surprising eruption of the Bogoslav volcano in the Aleutian Islands. The volcano produced a large explosive eruption followed by a series of explosions on almost a daily basis. Some of these explosions have reached as high as 35,000 feet into the atmosphere. The highly explosive nature of these eruptions is likely rooted in the interaction between the new magma that is reaching the surface and the abundant seawater that it meets when it erupts. That water can quickly flash to steam and help fragment the magma into ash, thus adding to the explosivity of the eruption. This image shows how the continuous eruptions at Bogoslav have demolished much of its Aleutian Island home. Alaskan volcanoes have actually produced 1 or 2 eruptions per year since 1900. At least 20 catastrophic caldera-forming eruptions have occurred in the past 10,000 years. The awesome eruption of 1912 in the Katmai National Monument is the most recent. Alaska normally records 3,000 quakes monthly, but now seismologists have already reached the monthly average in just 10 days. This unusual sequence comprises, among others, 3 earthquakes larger than magnitude 6, 7 larger than magnitude 5, and 50 larger than magnitude 4. The highest number of quakes recorded statewide to date came in 2014, when more than 40,000 were detected, an astonishing number. Mount St. Helens is one of those volcanoes that is unsettled in 2017, resulting in an earthquake swarm. The USGS detected over 120 earthquakes over the last few days, all occurring 1 to 2 miles beneath the volcano. Here's a look back at the shocking devastation left in the wake of the Mount St. Helens eruption on May 18th of 1980. We often associate volcanic eruptions with the earthquakes that precede the eruption. But what do we know about megaquakes? The largest earthquake ever recorded by seismic instruments on this planet was a magnitude 9.5 earthquake in Chile on May 22nd of 1960. That earthquake occurred on a fault that is almost 1,000 miles long and 150 miles wide, dipping into the earth at a shallow angle. So we know that megaquakes have occurred in our past and are likely to happen again. In fact, earthquakes of various intensity are capable of striking any location at any time. But history shows they occur in the same general patterns over time, principally in 3 large zones of the Earth. One of those zones is referred to as the Circum-Pacific Seismic Belt, the world's greatest earthquake zone located along the rim of the Pacific Ocean, where 81% of the world's largest earthquakes occur. Another of those zones is referred to as the Alpide. It extends from Java to Sumatra, through the Himalayas, the Mediterranean, and then out into the Atlantic. This belt accounts for about 17% of the world's largest earthquakes, including some of the most destructive. The third prominent belt follows the submerged Mid-Atlantic Ridge. This would include the New Madrid fault line. The last significant earthquake to occur in this area was in 1811 and 1812, the most powerful earthquakes to hit the contiguous United States east of the Rocky Mountains in recorded history. In fact, the New Madrid earthquakes were so powerful that they were felt over nearly 1 million square miles. Not only did the quake reverse the flow of the Mississippi, but it damaged the sidewalks in Washington, D.C., and reportedly rang church bells in Boston. The New Madrid is the least understood seismic zone in the United States. It has often been said that another major earthquake in this zone represents a towering threat for which the central United States is almost entirely unprepared. I'm sure you've heard of the expression that if an earth-shattering catastrophe were to occur, that California would eventually fall off into the ocean. Well, that saying is a bit exaggerated, but California is moving horizontally north towards Alaska in a type of sliding motion. The dividing point is the San Andreas Fault System, which extends from the Salton Sea in the south to Cape Mendocino in the north. This 800-mile-long fault is the boundary between the Pacific Plate and the North American Plate. The Pacific Plate is moving to the northwest with respect to the North American Plate at approximately 2 inches per year. Now, at that rate, it would take some 15 million years for Los Angeles and San Francisco to be next-door neighbors. Unless, of course, a major pole shift were to occur, in which case the timeline could rapidly change. One important result of earthquakes that should be considered is that the earthquake itself does not kill people. It is the buildings and the contents therein that cause deaths in seismically active regions. There has been larger earthquakes that have sustained very little damage, and smaller ones that have. It all depends on the manner, on the construction of the buildings, and the materials that are being used. Some buildings were never meant to withstand violent shaking. Much depends on two variables: geology and engineering. From place to place, there are great differences in the geology at and below the ground surface. Different kinds of geology will do different things in earthquakes. For example, shaking at a site with soft sediments can last 3 times as long as shaking at a stable bedrock site, such as one composed of granite. Local soil conditions also play a role, as certain soils greatly amplify the shaking in an earthquake. The looser and thicker the soil is, the greater the energy movement will be. Fires are another major risk during earthquakes, as gas lines may be damaged, which could dramatically change life in America overnight. Earthquakes are a powerful force that can change landscapes and lifestyles. But there is something even more distressing that earthquakes are capable of doing. Media sources have reported that the Chilean earthquake of 2010 and the Japanese quake of 2011 were so powerful that they caused a shift or tilt in the Earth's axis. The Earth, which spins like a top as it orbits the Sun, has its tilt permanently altered. If we evaluate the simple facts involved with these two earthquakes, then the probability of an axis tilt comes into focus. The earthquake that unleashed the devastating tsunami on March 11th of 2011 moved the entire main island of Japan by 8 feet. It also shifted the Earth on its axis by nearly 4 inches. Scientists who are familiar with the phenomena say that the axis being altered has led to the shortening of the day by 1.8 milliseconds. The law of physics implies that the axis of rotation doesn't change relative to other stars as a result of an earthquake. So if you were looking at the Earth from a distance, you would not notice a change in the Earth's orbit or rotation. However, because an earthquake moves the material around within the Earth itself, the position of the rotation axis changes. We call this the sloshing of the Earth's mantle, in which the crust actually shifts. So if it appears that a shift of the Earth's axis took place in 2011, it is because we use points of reference on the Earth's surface to determine if this has occurred, where the probable cause is more accurately described as a shifting of everything on the Earth's surface. Here then is a look at the devastating effects of a mega earthquake and tsunami that hit the island of Japan on March 11th of 2011. The events that alter the dynamics of our planet are a part of the puzzle that, when put into place, help contribute to the overall picture of a planet in turmoil. But there are other pieces of the puzzle that are not so easy to identify or to put into place. One of those pieces has to do with the unexplained wave anomaly that is originating from Antarctica. This activity is quite apparent if you examine the recent morphed integrated microwave imagery, as shown here. In April, the same type of activity and patterns were being produced from the same region. Due to the coordinates from which the anomaly seems to be originating, many believe that the waves could, to a certain extent, be linked to the Princess Elizabeth Station. The station is situated at the base of figures that resemble pyramids. You might have heard a while back about a report, although controversial, that former astronaut Buzz Aldrin, who had recently visited Antarctica, had tweeted a photo of a pyramid, explaining in his own words that evil is here. So what did he mean by his Twitter statement? His words were removed shortly after they were posted. It appears that yet another mystery seems to be originating from the South Pole that has yet to be explained. Take a look at this screencast from May 25th. If you look to the left of South America on this map, you will notice that the waves appear to be emanating from Antarctica and moving out into the Pacific Ocean. If you follow the pattern of strange anomalies here, then it certainly looks like something is happening that none of us can fully explain. But as I have indicated many times, the truth is out there. We just have to search for it, and one day, very soon, hopefully, we will find it. If you follow these strange anomalies happening in our sky recently, then you will understand that our atmosphere is changing dynamically. What may have been the norm many years ago is no longer true today. A perfect example of the changes happening in our sky comes from Borneo, and it has to do with light pillars. These anomalous pillars, which appeared over Borneo on June 22nd, are extremely rare. They are normally found in one location, the polar region, where light reflects off the mirror-like surfaces of ice crystals. Borneo benefits from year-round temperatures averaging 32 degrees Celsius, or roughly 90 degrees Fahrenheit, with a relative humidity of around 80% for much of the year. So how is it possible for ice crystals to form here, even at higher altitudes? It is absolutely strange, but certainly makes for a great conversation. One more thing I want to mention, because it has gotten a lot of attention over on our Facebook page. We recently received an image from one of our sky watchers who had this photo from February 26th, and he wanted to finally share it with our followers. It's a fairly remarkable capture of a planetary body that was briefly seen in the southeastern sky on that particular night. Now, as you may be aware, on that date, both Venus and Mars were located in the west-northwestern sky well above the horizon. Both were very visible, especially Venus, which was resembling the Star of Bethlehem with its extreme luminosity. Many of you commented how